What is going on, guys? Welcome back to your 10th physics lecture. And in this lecture, what I want to do is I want to talk about Newton's laws of motion, specifically his first law. But before I do that, I have to tell you guys a story. I just got home from going out to eat with my mom, and when I was at the little, I don't even know what it is, not a cafe, but I was at the restaurant, and I overheard some girl talking to her boyfriend, and this is actually a question that she asked him. She goes, "What part of the cow does the meatloaf come from?" Meatloaf. Can you believe that? That's what she actually said. But anyways, we're not here to talk about Meatloaf Girl. We are here to learn some physics. So in this tutorial, like I said, I want to talk to you about Newton's first law. Now, this was a dude that lived long ago, and he came up with a bunch of laws, but maybe his most famous was his first law. This is also known as the law of mass and inertia, and of course, it says an object in motion tends to stay in motion, but the full law is this. Actually, there are a bunch of different variations, but this is the most popular version. An object at rest tends to stay at rest, and an object in motion tends to stay in motion at a constant speed unless acted upon by an outside force. What the heck? What did I just say? It's basically this. That was the terminology they probably used long ago. But nowadays, it's like this. If you have an object and it's sitting there, not moving, it's going to keep not moving until you go up and kick it or something. Likewise, if you have an object in motion, like a space shuttle or something, and it's moving at 500 miles an hour, it's going to keep moving at 500 miles an hour unless acted upon by an outside force, aka a meteor or maybe the force of gravity. So that's basically what it means. Why we have to define this, it seems common sense to me, but this old dude decided to put a couple laws on it, so now we are stuck here having to learn them. Another thing that physicists decided to do is they wanted to add some terminology or vocabulary because this wasn't just easy to understand enough. They had to make it confusing a little bit. They said all objects have something called inertia. Now, inertia is the property of matter that causes it to resist change in motion. So it's basically the property that keeps things standing still or keeps things moving. So one of the factors that you need to take into account whenever you're calculating inertia is mass. So therefore, mass and inertia are related. Therefore, even furthermore, the more mass an object has, the more inertia it has. So let me go ahead and show you guys an example. Say you had a big refrigerator that was 70 kilograms, and you had a smaller mini fridge that was only 30 kilograms. So, according to Newton, since refrigerator A has more mass than refrigerator B, it therefore has more inertia. So, therefore, it was more likely to resist change in motion. So, if you had to decide whether you wanted to move A or B up the stairs, you obviously would choose B because why? Well, obviously because it's smaller and weighs less, but the technical physics definition is because refrigerator B has less mass and therefore less inertia. Therefore, according to Newton's first law of mass and inertia, it would be, easier to move, so on and so forth. You get the point. So let me go ahead and show you guys one more example before I let you guys go, and that is the famous, well, this actually isn't famous. I'm probably the first one to ever do this example, but say you have two balls traveling at the same speed, two huge balls. Go ahead, bring on the jokes. So you have one that's 80 kilograms, and you have a smaller ball that's only, let's say, actually, they almost look the same size. That's only 20 kilograms. And they're both traveling, whipping through the air, wee, wee, same exact speed. Well, even though these are both bowling balls, let's say, and they're traveling at the same exact speed, the 80 kilogram bowling ball would be harder to stop than the 20 kilogram bowling ball. Why? Because the 80 kilogram bowling ball has more mass, therefore more inertia, therefore it's more resistant to change in motion. So just remember that. I know this is kind of obvious stuff. Obviously, the heavier something is, but Newton made all these laws, and therefore we as students need to learn them all. or else, you can't get your degree or you're going to fail your test. So thank you, Newton, for all that stuff. So anyways, I'm going to go ahead and probably make a meatloaf right now. You guys watch this video again, and once you grasp this knowledge of Newton's first law, I'll see you in the next video where we're going to be talking about Newton's other laws.